So I've spent 3 days on this project and it's finally time to check out whether this will work or not. Tic Tac Toe with football. Let's go ahead and try it out. So you might have come across interactive football videos like this. These look amazing, but there is one big problem: the cost. In this example, they start at 13,000 euros. I mean, that's a lot. The question comes, can we do a similar thing and how much will it cost? But before we do that, why exactly do they cost so much? It's because of these sensors that are put around the wall to detect the hit. Being of computer vision background, we are going to do this with just webcam. But how much will it reduce the cost and will it be the same accuracy? Stay tuned to find out. So here's the plan. We'll first look into the hardware and then we will start with the software. Hardware, we will need a football, a projector and some cameras. So let's go ahead and first get the football. So we have a few options here. The best one to pick is the one that has a lot of variations. So I bought these two balls, so we have different variations. Now let's go ahead and check which cameras do we need. So we have a big issue with the cameras. We have too many to choose from. First world problems. Now we are going to pick a portable projector. I'm a bit tired, so we'll use Amazon. So after a bit of research, I have found this projector. Let's go ahead and purchase this. So let me show you a fast delivery method from Amazon. There you go. That was easy. So this wall looks like a good area to get started. So let's clean it up and set up the hardware. So now we need to fix the projector and the camera, but we cannot just place it on the floor with the tripod because the ball will hit it. So instead we are going to use this table to fix the projector and the camera. So adding the projector here on the tripod has some fixation issues. Not able to resolve this, we can simply place it on the table. So now you can see that the projector has been fixed on the table and it is projecting, but the issue is that it is a bit tilted. So unfortunately, I just figured out that this projector does not have an horizontal keystone, so we cannot adjust this. But luckily, I do have another projector lying around. We will try to use that instead and see the results. So as you can see, the projector is all set up now and the image quality is much better because it's a much bigger projector. So let's go ahead and fix the cameras. But why do we need two cameras? The first one will solve the question of when and the second one will solve the question of where. We will attach the first camera on top of the projected screen to know when did the ball hit the wall. The second camera will be attached on top of the projector to know where exactly did the ball hit on the projector. For the first camera, we are going to use this 60 fps wide angle lens so that we can see more and we can react fast. We can place this camera either at the top here or we can place it here. The second option will work better. So let's go ahead and try that out. Now that the camera is fixed, let's go ahead and test if this will work out and detect the hits. As you can see, the camera is now fixed. Now what we need to do is we need to code and see if it will detect the hit. The idea is to get a 0 or 1. 1 if the ball hits the wall, 0 if it doesn't hit. So let's go ahead and code. The initial code is now done, and as you can see, this value here represents the white pixels that are detected by the motion. So here, if I throw a ball, you will detect a hit here. So here you can see when we hit the ball, all of these detections were detected. But the problem is that these are multiple detects, so we need to fix that so that it detects only once. So now we have added the cool time of 0.8 seconds. Multiple hits should not be detected now. So let's go ahead and test it. Let's attach the second camera now to find where did the ball hit. So here you can see the webcam is working and it is able to see the complete projected image. For detecting the ball, we can use the YOLO method. These detections will not be that great. So we can use YOLO to label our data, and then we can train our own custom model, which will perform much better than the default YOLO method. So first we are going to write a YOLO script to check if it can detect balls by default or not. So right now we are running the YOLO method by default, and you can see it is detecting the sports ball. That is good, but when it's in motion, the detection is not that great. So we are going to collect our own data and we are going to save it in YOLO format so that we can train a better model and we will get some better results. So here you can see the data has been collected, and if I move around, you can see the detections are good. We are using 420 images to train and 120 images to validate. The training has started. So now the model has been trained, so let's go ahead and test if it will work or not. Now that the motion and detection both are working, let's go ahead and merge these two codes together. So here you can see we have both the cameras running at the same time, and here is a perspective view of this so that we are only getting the screen out of this. Then we have also created this dummy screen that we are going to bring it to our projector, and this black screen will display the dot where the ball hit. Let's hit it and see if it works. It does work, but it seems that there is a calibration problem. It's hitting somewhere else. So the second time around, it's not working at all. So let's go ahead and see what's the problem. So if we look at our code here, you can see the ball hit was detected, but it's not being displayed on the screen. So that's a different issue. So let's see what is the problem with the software. I've spent almost a complete day on calibration and got some good results. Let's go ahead and check them out. So now that it works, let's go ahead and create some games. Since we saw the demo of the Tic Tac Toe game, we are going to create that as well. So I've completed the Tic Tac Toe code that is copying from ChatGPT. So now let's go ahead and test it. So here is the game. All you have to do is click and it will place the markers for you. Once it's done, it will tell you whether it's a tie game or did somebody win. Now we will go ahead and merge these two codes together so that when the ball hits, it actually creates a mark on the Tic Tac Toe game. So I've spent 3 days on this project and it's finally time to check out whether this will work or not. Tic Tac Toe with football. Let's go ahead and try it out. Here you can see where did the ball hit, and it also shows you the motion detection camera that detected the motion. Not good with football, but we need to do some more testing. Here you can see a controversial hit, but because the center is at this point, that's why we got a tick there. So let's go ahead and discuss how much did it cost. The projector was around $800. Both the cameras plus its wiring cost about $100. You will also need a laptop, which is around $1,000. Total cost will be around $2,000 if you use the expensive stuff. But if you already have a laptop and you buy a cheaper projector, you can create this project in just $500. So what about the accuracy? The accuracy was around 60 to 70%. With a little bit of more tuning, you can get up to 80-90% of accuracy, which is very good if you are playing and it's not a very serious sports activity. So this is it for today's video. I hope you enjoyed this video and you loved the project. If you did, share it with your friends and let me know in the comments below what would you like to see next. See you in the next one.